Okay, this is example number 1 of section 16.3. So we have a motor that turns the gear A with an acceleration of 4.5 radians per second squared. This gear is leading to move that gear B. So let's call this gear A, this big gear B, and that attached to the gear B we have another gear D. So the gear D has the same velocity and acceleration of gear B. And we are being asked to find the velocity of block D, let's call this block D, the velocity of block D and the distance it travels in 3 seconds. We have to relate the angular velocity of this gear A with the motion of this big gear and the motion of the smaller gear and the motion of the block D. How do we do that? The first thing that we have to know about gears is that the point where they connect, it has the same tangential velocity. So anytime that we have a gear over here and a gear over here, so we have this point, I call it P, the velocity here is exactly the same. So they are touching and they transmit the same velocity and actually also the same acceleration. So that velocity is equals to this velocity and this tangent acceleration is equals to the tangent acceleration. Be careful that since this point has a curvature path, the acceleration has 2 components, has the normal component, let's call it PA and PB. So we have 2 different points that are touching and this is called this PA and this is NPB. Those 2 accelerations are not equals. The normal accelerations are not equal, but the tangential accelerations are equal. So let me just make the statement that point A is different from the normal acceleration of point B. So those are different, but the tangent acceleration of point A is equals to the tangent acceleration of PB. The solution, let me write it here. The first step, we will relate acceleration of gear A to gear B. And I will do it using that statement that I just did, that those 2 accelerations are equal. And the tangent acceleration, we remember that the tangent acceleration of that point P will be equals to angular acceleration of A times this radius, so radius of A. And it will be in the negative direction, right? And that same acceleration will be equals to, I said already, to the other point, so that will be equals to positive, right? As you see, both accelerations go in the same direction, so I can actually talk about only magnitude. So from here, I can relate that the angular acceleration of this big gear will be equals to the acceleration of A times RA over RB. So that's my first relation that allows me to find the acceleration of the bigger gear knowing the smaller gear. And if we plug out the numbers with RA equals to 75 millimeters and RB equals to 225 millimeters, we have to, and we know the acceleration of A, which is given, we know the acceleration of B is equals to 4.5 times. Since those are the same units, I don't have to put it in meters, so that will be 75 over 225. So the acceleration of B, I have the value right here. The acceleration of B is equals to 1.5 radians per second squared. So as you see, the gear B goes slower than the gear A because it has a bigger radius and it has the same tangent acceleration in this point. The second that we'll do is relate angular acceleration of gear B to gear D. And as you see, since they are both attached, they is the same, so the acceleration of gear D is equals to gear B, which is 1.5 radians over second square. We want to find the value of this point because since this is an inextensible chord, if I find the velocity of that point, I will find the velocity of that. So I need to find the linear velocity of point P dot or P prime to find the velocity of D. Obviously, I already know that this is moving this way, so this is moving this way, so this is moving this way. So my velocity here, let me write it as a vector right here. Velocity of P will be the same as velocity of D. So how much will be the acceleration P prime? The acceleration of P prime, the same concept that we got here, right? So it's a tangent acceleration that we care about. We do have a normal acceleration, but that normal acceleration will not affect the acceleration of the block D. So I will say the tangent acceleration of P prime will be equals to the angular acceleration of D times that radius. And that radius is 125. So it will be 1.5 times, if I want to find the linear acceleration in meters per second, I do have to convert those units, so that will be 0.125 meters. So I got here that the tangent acceleration of P, which will be equals to the linear acceleration of, let me write that here, acceleration of D, 1.5, that will give me a value of 0.1875, and that's the units of that acceleration is meters per second square. Okay, having that value, they asked me to find velocities, but since I was given accelerations, I cannot find velocities yet with these relations. But now, how do I find velocities having the acceleration? So the fourth step, since this is a constant acceleration, I can just use integration of accelerations to find velocity and position in seconds. So we know that velocity, final velocity after 3 seconds, right, will be initial velocity plus acceleration times time. And since that block started from rest, this is 0. And I just have that the velocity will be equals to 0.1875 meters per second square over second square times time, which is equals to velocity of D, 0.563 meters per second, and that's in 3 seconds. So now we did find the velocity, and to find the distance traveled by the block, we use that the distance will be the integral of that velocity will be S0 plus V times velocity, initial velocity times time, plus acceleration of that D block times time over 2. And since we can put a datum where it started at 0, displacement at 0 time, so we can say that this is 0, this is also 0, and then we have that the displacement of D, which will be equals to the same acceleration times, now times 3 squared over 2, and that gives me a value of 0.844 meters in 3 seconds. So we were able to first relate the acceleration of this gear to the acceleration of this gear to the acceleration of this gear and to the linear acceleration of the block. And since that is a constant acceleration, because we were told that this is a constant acceleration, we were able to integrate that acceleration to get the velocity and the position. You can also see the solution in the PowerPoint presentation.